If 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 you are able to download Toposit, fine. Otherwise, this can be quickly downloaded. Anyway, purpose is to GeoRef the unprojected map. So this is unprojected map.
So
You
we
have
have,
coordinates.
sorry to interrupt, sir. So we have to save it as an image. Save this one that you shared, because after clicking on the free download option, it's not getting downloaded anywhere. It's just opening in a new tab.
You just you just press Control S, Ayushi, and then it will save as JPEG.
Okay, okay. Thank you.
So download this and start using this. Are you able to find the option? If not, do you require any plugin? You have to think. If you are getting the option, it's fine. If you not, see the required things are set or not.
So we have to add it in the georeferencer window, right?
Do you have option in your layer menu? If it is
Yes, sir.
coming,
I
Yes,
think
sir.
it is inbuilt. Georeferencer is inbuilt. Two windows open: the main window and the, I think, the GCP window.
no,
So
no, that is right. But if you have different version, maybe everyone will not have same version. Just check if the option is not available, then let me know, or you have to install some plugin. Like for his case, it is available by default. So that depends. If not, if you don't have that particular option, then let us see. If you have, then go ahead. Where is the option, in which tab? Is it in raster or is it in layer?
it is in layers.
Layer. Okay.
Yes.
So for everyone, it is in layer.
Yes, sir.
No one is having in raster, right? Okay, fine. You follow the steps and let us see the output how it is coming. So where you will get the ground control points? From where you are using ground control points? Everything depends on these. So if you are using Toposit or you are using other map which is downloaded, so ground control points are there on that map. Okay, so use only that one. Otherwise, it will not project properly. I will show from where you have to use the ground control points. Where is the map? Yeah. So where you are, see, while selecting the ground control points or the points for georeferencing, it should be triangulated. So what I mean, triangulation means, if you are, my screen is visible, no? Can you confirm? Someone? Okay, thank you, Abhimanyu. See, if you are taking one point, for example, here in this corner where my cursor is there, so you should form triangle, like one point here, another point here, another point here. First 3 points. This selection is very important. And once you select, for example, this point, you have its coordinates here at the location. Okay, so first 3 points should be triangulated. Rest you can take randomly. First 3 points are important because it is using triangulation, so accordingly it will place your map.
So we need just 3 points, sir, if I understand
No,
correctly.
no, 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 no. Three
I don't
points are
quite get
three,
your.
3 points are minimum. You are right. Even if using 3 points also, you can perform the operation, but take more points to increase the accuracy. Also, remember what to enter in X and what to enter in Y. If you enter in reverse way, the map will be just turn around. So either easting you called or longitude you called, it has to go in X field and latitude and northing in Y field. If you enter in reverse way, you will not able to achieve. Whatever points you are marking on the map, you have to zoom sufficiently, otherwise point will not be precise. Abhimanyu, number of points depends on the which method we are using for the transformation actually. Here you are going to use polynomial 1. So there you require minimum 3 plus 1 point. So take more than 4 points.
Sir, when we mention the XY coordinates,
Hmm.
how do we like? I think there is a way to write like for degree and minutes. Do we use decimal to separate degree or minutes? Is if I'm not remember like able to recollect.
What option you are getting? Degree minute second or degree decimal?
So degree minutes, 72 degree, 15 minutes. That is the first point. So how do I write it in the coordinates?
No, no. In coordinate on map, what because everyone is using different map. That's why little confusion.
Yeah.
On map, what you are getting? Degree minutes second or degree minutes only?
So degree and minutes only, no seconds.
And there you are getting second also. Degree minutes second or degree decimal.
So there is this only option like for writing the x coordinates. So I was asking, how do I write? Like only the 72 degree, just that, or how do I mention the minutes portion?
No, it is asking. See, there are two units actually.
Okay.
One is degree minute second. This is
Yeah.
one unit which and another part is degree decimal. So there you will have x like 72.53 something
Okay.
like that. So what option you are getting? The second one is getting there.
Yes, sir.
Then you have to convert this degree minute second into degree decimal.
Okay, sir.
Or maybe to cut short the time you can write 70, but you have only one box. Can you project your screen?
Okay, sir.
So it will be solved for one in all.
Is it visible, sir?
Let me check on that. Yeah, it is coming.
So, sir,
Ex-
for this point, which I have added, I was gonna write 72.15 for
So
this word.
72.15 is on your map. 72 degree 15 second
15 minutes, sir.
minute. Yeah. So
So,
one option is you can convert into degree decimal
okay.
and then put. Just let me put you link online conversion. There is formula, but anyway, for this purpose you use directly. There is formula you can put. So let me put the link here. It's simple conversion. I have shared the link. You just convert your degree minute second into degree decimal. So you have 72 degree
15 minutes.
15 minutes and 0 seconds. Convert to degree decimal. So yours is coming 72.25 something degree decimal. So
Okay, sir.
you can convert it and write. Second, you have to give 0101. You give
So only
just
00.
00. It won't take. It will take 01. In fact, to the precise, you can reduce second and add into it. But you just for exercise, you make 01.
Okay, sir.
So it is coming 72 to 5 something.
Yes,
Because
sir.
the units are different, we are using different map. In fact, we can change the unit same in the QGIS. But anyway, now you convert and add.
Yeah.
Taking.
Yes,
So
sir.
you have added first point. Now second point will be away. You have to make a triangle, and fourth point you can put anywhere, but try to put that fourth one is also little apart from these three.
Okay, sir.
So accordingly you put all 4 points and proceed. Okay, you can unshare.
Okay, sir.
So the 4 points will be, sir, the four corners of the image.
Yeah, you can put on fourth corner, but not near to the any of the 3 points.
Yeah, and you were saying that we add 1 degree. I do not understand. So 72.25, we still add. Can you please
No,
explain,
no,
sir,
no.
that?
Actually, see, the link in the your practical manual, which is giving, is a little complicated. It is asking some documents and all. So we are not using same map, which was 45 H by 10, not possible to immediately download. That's why we have taken shortcut. We have downloaded another map. There you have only degree and minutes. That's why we are, and now she has taken degree decimal there in QGI georeferencing. So we are converting this degree minute second into degree decimal, this unit conversion, and putting there.
Can I
If it is
remove it?
same on both the your map as well as in QGIS, no need to convert. You can directly add into degree minute second. But software is also giving option to change your parameter units. But anyway, now you proceed.
But here it is saying that enter G, X and Y coordinates, DMS, DD or projected coordinates. So either we can, rather than using that link to convert, we can
Yeah, you
directly.
can use degree minutes second. Exactly. If we keep the both the units same, there is no need of conversion. Directly we can use. But she was already in between. That's why I shared the link for conversion.
It seems that there is a slight change in the clarity of the layer of the georeference layer and the original layer.
Mm,
The georeference layer is very it is not clear.
just share your screen.
Sure. So, for example, this one is the georef layer.
Mm.
Here you see that the even though it is georeferenced, like the coordinates 72 to 24, those what we saw, but the clarity is not. So if you see the original this thing here, um,
You right click on the layer and zoom to layer because one is projected, another is not projected. That's why it is not coming. Zoom to layer.
this one zoom to native, zoom to layer. Yeah, here you see it is much clear and we can
No,
read
here
all these.
also you zoom it.
In the other
Uh,
one, here it's much clear. You see here, it's at least I can read causeway it's written. But when I go to that layer, I go to zoom to layer. Here it's not readable only. So the clarity is gone.
yeah, this is because the precision of point matters. If you see your points, you adjust your points exactly on the pin location, zoom it, zoom on the map, and then adjust your point because if one of the point is moved little here and there, that will also create difference.
Okay, so I should have zoomed as much as possible and then added
Yeah,
my control.
yeah, your point should be precise.
Okay, I see. Thank you very much.
But anyway, you have completed this process, I think. uh, though little adjustment you can refine the point, it will come. Just one of the point is little away, that's why it is coming like this.
Thank you.
And let me tell you, this type of georeference is the comparatively easier, and it is giving you immediate good accuracy because you are just using one map and using that coordinate you are projecting the same map in different format. But if you don't have these coordinates on the map and you have to georeference it, so how you will do it? You don't have coordinates, you have only map. So then it becomes little tough. Either you should have another map of same area which is georeferenced. So there are ways to handle this situation. For example, you have map and you don't have coordinate. Then you have another map which is projected. So you can use that projected map and bring its coordinates and project this map which does not have coordinates. So there is separate process for it. I don't think it is there in your syllabus, but for additional information I am telling. So you can use projected map to project unprojected map. This is one situation. Now, the second situation is that you don't have that projected map also. You have simply map and you want to project and use in GIS. So what you will do, you will take this map in the field, identify identify certain features at least in different uh, locations. Those locations again it should form triangular shape. So you identify few points, capture its latitude, longitude, geo information using GPS, handheld GPS, and you come back to lab and select that point like this method you have selected and you have entered its coordinate. Tick mark the point and fit the ground control points which you have collected using GPS and you can project. So these are the ways you can handle the different situations in a GIS. Okay, path is writing done with exercise. It is now showing coordinates on the map. Use 3 points here, making it triangular pattern. Okay, good. So I think Parth and Abhimanyu, you both have completed. So what about others?
Sir, I tried to do it, but I think I've taken points much closer. So I'll try again once later.
Okay, but you are okay with the process, na?
Yeah, the process is fine, sir.
Yeah, you. In fact, even if you because your map is having 0 0 seconds everywhere because it's a large scale map, bigger map, and that's why in Abhimanyu's case also features are little blur. So if you don't want to convert, you just use degree and minute. That will also work for you because there is not much difference in degree decimal and degree minute second because map is bigger. That will also work. See,
Okay, sir.
georeferencing is very precise activity. Here you are just learning the flow, how to perform this activity. But if you want to achieve precise accuracy, one map georeferencing will take half day. So you will play with the error matrix also. Error should be minimum. Then RMSE should be this much. So to adjust all these factors, you have to work very closely with your point on the map and its coordinates. So practically doing, if you want to achieve greater accuracy, like if you are working on meter scale, say 4 meter, 5 meter, then your map should be that much accurate. If you are working on a coarser scale, it will not matter. But if you are working on very precise scale, then georeferencing is a skill, I can say, is a skill. So how precisely you are marking point on the map, that is also skill. But anyway, this is simple exercise, nothing to worry. You can do it very easily. Path adjusting your error table is something to play with your points. So until and unless you move the points or you add the points, more points in the map, you will not able to reduce the error. Because and the moving the point is not like if you move one point, either error will increase or decrease, but that will not solve the problem. So all the 3 points, they should be moved in coordination to minimize the error. Minimum the error, better will be the accuracy. But minimizing the error requires bit time. You have to play with the points, then only you can minimize the error.
So what is this number? It's a 3.9, 0.98. How do we calculate the error?
No, error software is calculating for you automatically. This is the statistical metric. I think that is you might be getting one table, error matrix table. For each ID, say for example ID number one, there will be X and Y source. It will give it will give the residual error for that particular pixel. So if you are getting less than one, it is better. So this is calculated on the basis of number of pixels in between the each points, their distance and location of your point, and the assigned values of x and y, or easting or northing, for the ground control points. So error is calculated based on that. In fact, if you have more points in the data, you can uncheck some of the points and see the error is increasing or decreasing.
Where can we view the error, sir? Like, where should I go to see?
Let You have to project your screen, uh, or have you saved the GCPs? Mm, but you have run this one, na? Have you saved the GCPs, raw this file, GCP file? We can load it again, or you simply run it. Yeah, it is there, na? Down somewhere it will be show you the mean
Um,
error.
yeah, mean area is in the bottom. Right, yeah,
Yes, yes.
mean area.
You switch off any one point and see the error.
Yeah.
Out of four, you just switch off one. It is changing. No, minimum three you have to keep. In fact, it require four. It is changing. You see the mean error is changing. Even residual also changing. See, practically what we can do, we can see which point is having maximum error. Like your point number 4 is having 3.7. So it is creating maximum residual contribution. So this point is having some problem, point number 4. Even in fact, point number 1 is also giving 3.8 now. So that also have some error. But here we are just predicting point number 1 and 4 is having error. But it can be other way round also. Point number 2 and 3 might be having some error. So it's hit and try. You have to reduce the error. Less the error, more will be the precision and accuracy. So when practically you are doing, you may be having 20-25 points in your kitty. So then you can play with the points. You can even delete some points. You can add one more point if you want. Because it's very big map. Normally if it is small map it will work. Take in between, it's 25 na. 25 7. Take one point in the middle of the map. Abhimanyu, you can add one or two point anywhere, maybe middle or somewhere, and you can see the error because this is a very big map. See, 22.30 is coordinate for this line. Similarly, you have to see left side or right side of the map, what is the coordinate coming, where you are putting the point. So here is what, 20, 24. So accordingly, you have to coincide this vertical and horizontal line and add that coordinate into your table. What is the number here? 70 on top, 70, the line which you are, let me check, it's very small, I will check on my map. 3430.
I had actually zoomed a lot when I had chosen this GCP, but still, sir, in the new one, it is not that clear.
Okay, can you come to your error table again?
Where, sir?
Error matrix,
In the error.
the table which you were showing earlier. No?
Yeah, so it seems that I added actually 2 points, 4 and 5, and these
Hmm.
were not very far away from each other, but I had zoomed a lot for point 5. And if you see, the error is actually 0.06 now. Earlier it was 3 or 4, or even more than that, but now it has considerably reduced after I have unchecked 1, 2, and 3.
Mm, but you have only 3 points now in this one, huh?
Yeah.
And these points are nearer or far?
These two are actually very near. They have the same coordinates, but in the it is this one is more zoomed in.
Hmm. No, but you can reduce it. This all depends on the points, nothing else. You reduce the error, automatically it will improve your quality.
But what you said, what you had advised earlier, that when I should have zoomed more in order to see my um, new modified georeferenced
Hmm,
file
hmm, hmm.
clearer. But now with these 3 points, actually these are 2 points. It looks one, but actually these are 2 points somewhere. So still it is not that clear when I zoom. I cannot read.
No, but these two are very close, na?
Yeah.
So they will not add anything, I mean, much in the quality because they are near. See,
Okay.
basically, what it does, say, if you are making a triangle, so it will place all your pixels accordingly. So the shape of pixel, each you can say object should remain same. If for that all the points should be placed equally and their coordinates should be proportionate. If there is little ambiguity, then it will drift your objects either left or right or any direction. It moves 360 direction, you can say. So it all
But then,
depends on the points accuracy.
sir, at the same time, the error is quite less.
Error is less because points they are precisely placed, but they are near. See, if you have 2 points nearer, the they will talk each other very nicely, and but the area which is far away, slowly it will get drifted. So for that purpose, you should have 1 point away also, because that
Okay.
area how it will be taken care.
So by drifting, it means what you said, ambiguity, right?
Yeah, it is ambiguity. What will happen slowly? One thing is look and feel of the feature, but if you actually map, say for example, one area which is away from these points is having say 100 square meter, but because it is away and not properly georeference, instead of 100 square meter, it will say 98 square meter. So that type of error will occur slowly.
I see. Thank you, sir.
Yeah. But anyway, you can achieve. In fact, this map we have suddenly downloaded on the website uh, because error is dependent on many factors. If it is scanned, then the scanning also includes some error. I mean, there are many factors, but procedure wise, you are okay. Error can be minimized. So, everyone is okay with the georeferencing? Give me thumbs up so that we can try to move ahead. 1, 2, 3. Okay, 4, 5. Okay, fine. So this completes our georeferencing part. So if you have one map which is not into uh, projection system and you want to bring this into the GIS, so anything in the GIS without projection is useless. There is no meaning. So any layer which you want to use in GIS should be projected. That is the first step. So you know now how to project it. So you can assign it projections to it, and you can use this map along with your other layers. Otherwise it will not sit at its place, it will run here and there. Okay, so
Just a
yeah,
small, sorry to interrupt, sir. Just a small clarification. So here we have not projected, right? Here we have only geo-referenced.
yeah, georeference means you have projected only. Na? You projected means you have assigned projection parameters. That is nothing but georeferencing. See, georeferencing is a little broad term. You will come across georeferencing, you will come across projection, you will come across geosetting, reverse shading. So all these are the parallel words with very thin line difference. Coordinating. So
So
everything mean is that you are bringing this map with proper projection parameters so that you can use in GIS. Yes,
So even if we don't explicitly mention the projection, whether it's azimuthal or UTM or conicals, and it can still be called projection. We have only geo-reference. We have not given any
no,
projection
no, no,
like
no,
that
no.
in that sense.
Without that, georeferencing is not possible.
So here
No,
it has assumed some kind of projection already.
no, it is there. It was there when where you were opening the dialog box. By default, it was there, and in the small triangle was there. If you click on that, you will have all LCC, WGS, everything was there. Maybe you might guys might have taken by default what is it is, but you can always change. The option was there. The first step is that you have to assign that, and then you have to go further.
Right, right. So it said target CRS and I chose UTM zone. So that's why
Ah,
it's
exactly,
UTM
exactly.
universal transfer
Yes.
spectator. Okay.
Without that it cannot happen. It cannot move also, because that is the main basis. If you have chosen UTM, then all the parameters, like you are doing transformation now, you are transforming this map onto some projection system. The meaning is that you have a 2D paper map and you are putting on earth surface. Earth surface is, it's just like a ball. It's a spherical surface, so you are putting 2D on spherical surface, and it's 2D is a flat. You are putting this on some conical type of the surface, so it has to be curved. And the reason for getting error is that one, because map is a plane, you are putting in onto a spherical surface. So everywhere it is, say roughly, very crudely, if I want to explain, I will explain that you are putting a piece of paper on a some football. So then it has to give error everywhere. Only it will not give error where the top portion which is touching X. If you go away from that touching point which is on the top of the ball, everywhere it will create error. It has to create error because 2D and 3D there is a difference. So what the projection like WGS and LCC in this, what they are doing, either they are some projections they are keeping area constant, and some projections they are keeping your shape, fixed shape. They will not allow to change the shape, but they will compromise in the area. Some of the projections they will compromise in the area, but they will keep the you compromise in the shape, but they will keep the area constant. So based on this principle, these all the projections they are working, they have their own algorithms. So this is the basic step. You choose WGS84, whatever conical is there. There are few, so you select one where you are working and what is the purpose. Do you want to keep your shape as a constant, area as a constant, and which part of the earth you are working? If you are working towards say north end of the earth, there you have to use different projection. Why? Because earth shape, you consider earth as a whole, as a goal, like a ball, then their situation will be different. If you are working in northern hemisphere or southern hemisphere, uh, in the middle, that their situation will be different. So that is the first step. You have to select the right projection, and then you have to assign the rest of the things. But all your calculations, when you say you have used polynomial to transform, so when you are transforming this and you have selected WGS84, so all the parameters which are assigned with WGS84, they will be automatically implied on that. That's why your map, when you are putting in a WGS projection system, it will exactly fit on its place. For example, if you are using some Lambert conical and you are fitting into the WGS 84, so there will be slight shift. And that is the reason, if we are using our digital topo sheets of Survey of India, which is on LCC, and you are fitting it with, say, some of the open source data globally available, which is in WGS 84, so you will feel little challenge because they will not exactly fit. You have to do some adjustment here.
So so because I am actually, my background is not geography, so I have also been reading and first following some online
Okay.
courses. So if my understanding was that prior to your this thing that WGS 84 is like a datum,
Hmm.
and further we assume local variations in the shape of the Earth, and that's kind of a global datum.
Yes.
And for the once so we select, so that is a separate thing, and once the datum is there, then we can add the different projections. So that was my understanding. So now,
Right, right, right. That is the base actually.
so so WGS 84 can have different projections, right?
Yeah,
And
it can have different.
UTM. Okay. Yeah.
But the
Thank you.
calculations, all the calculations will be with reference to WGS 84, because each one is having its own setup. WGS 84 is having its own setup.
Yeah,
So
yeah.
accordingly, you can add on top of it. You, in fact, you can transform also later on. Okay, I think now let us move to the next part, the vector part. Uh, okay, you are comfortable with georeferencing? I believe so. Okay, okay. So good. Okay, now we are going to create our own vector layer here. So you can open exercise number 10. So let me, I'll give just very brief demo, and then you can create your own layers. So what layer we are going to create? We will create one point layer. So why point layer is required? Because if you are mapping any point data, say if we take the example, you want to map the electricity poles. Okay, this is the requirement. So what you will do, where at every place of the electric pole, you will put a dot or point. First point you will put, then second pole you will put point, third pole you will put point. and then you will give the attribute. Okay, pole number a 1, say attribute number a, pole number b attribute b, or pole number first point 1 2 3 4, you whatever attribute you want to give, you can give. So this is your point layer. Another example, you want to map the villages. You don't want extent of villages, how big, how much area it has occupied, that is not your objective, but you want to know the location of the village. So there also you can use point like village, say xyz, one pin, one point you put some another village, nearby village another point, another point. So and you can give the village name to that in the attribute. So in this way you are using the point data. These are the point layers. So we are going to create one point layer. Now second part of the vector, what we are going to create, we are going to create a line layer. A line, sometime called arc also. So line layer like for example, you want to map the railway network of India or road network of India. So how you will map? So you will draw a line. See, for example, line from Delhi to Meerut, either road or railway, this line. So you will write national highway so and so, yeah, rail route so and so, southern railway, eastern railway, whatever. So in such scenario, you can put a line layer, or you want to map a canal layer of the India. So whenever the canal moves, you will create a line layer, and you will give attribute. Okay, this is the main canal, this part attribute. Then another part connecting to this is submain canal. So there will be two or three submains. So then further tertiary canal. So in this way, we can create the line layer. So in GIS, always we need to ask the question to ourselves, why I am doing it. If I want to map, say I told you like road and railway layer, you can put a line layer, but you have to ask question, what is the purpose? If the objective is to understand or to analyze the area occupied under road, area occupied under road, please pay attention to this. So what you want to know the area. So then you can create polygon also depending on the width of the roads and canals and railway line. So there you can create polygon also, so that you will get the area through polygon layer. Or else you can create line layer if you know the width of the road, say you know 20 feet, this type of road belongs to 20 feet or 30 feet. Then also based on the length you can calculate the area. So always we need to ask question to ourselves. So what is the purpose? What ultimately I am going to achieve with this particular exercise? Then you can put the right data in place. Okay. So point, line, and then one more thing we are going to create here is a polygon layer, or area layer is also, it is called as area layer also. So where this area layer can be used, now you want to know the extent of the villages or extent of the cities. So basically you want to know the area. So in when you want to know the area, you require polygon layer. So polygon layer can be created as an area of any habitations, or to map the forest, to map the agriculture, land use, land cover, to map the soil, to map the geology. So all these type of applications we require polygon area or polygon layers. So this is basically the background, what type of layer you need to create. Sometimes some of the project will require all three, because you can overlay one on top of other. There will be, say, land use, land cover layer. There will be soil layer. There will be water resources layer. There will be geology layers. There will be road network. There will be village location. So all some of the projects will require many layers to combine together, and once you created all these layers, then you can go for the analysis in the GIS. Like you will be having, say, point or polygon layer of different villages, one part. Another layer you will be having road network. So based on that you can find out, I want to reach from this X village to Y village, what is the distance and what are the options. So then you use the network connectivity, network analysis, that is called in GIS. So once all the layers are used ready, you can use the network analysis and you can find out this type of analysis and options. Okay, so I'll just give brief demo and I want you yourself should do, so that you will find out the difficulties you are facing. So I'll put simple demo. Okay, this is file available. I'll use this. So first of all, you have to create a layer, new layer. So there are few ways, but easiest way, you go in layer and you say you have used this option add layer. This is for existing layer, once you, either you have created or you have available in your system, you can add. On top of this there is a create layer option here. Now in the create layer option, what you are going to create, you have to give the option. Here we are going to create a simple save file. So I will choose save file. Now once I have choose this, a dialog box is opened, and this is I will give demo for one. This is true same for all the vectors. Okay, so first of all file name, and I have to save it, no. So maybe temporary I'll put on desktop, and I will give some name temporary. I'll put Equino IGNO. Okay, this is my temporary file name is an save file. I will say save. So this is my file name and the location where I saved. Let it be file encoding as it is geometry type. Now here you have to select what type of geometry you want. You want point, line or polygon. Okay, so any type, say I'll select poly, any layer I'll say I have selected polygon. If you want to create point, you can select point, rest of the things will be same. Now which field you want, you have to give the field name. Field name means, like I have created a polygon, so they, I have to name it, na, what it is it well or is it reservoir, is it habitation. So that field name, maybe I will put some name here. Land use is my name. Hope it will take. So what type of field you want? You want to put memory or you want to put some text? So that you have to select. So for this, I will take say text only. And what is the length? I mean, how big names you are going to give? Are you writing a sentence or will it be one word, two word? Accordingly, you have to set its length. So I am not going to write much. So I'll put 25. Okay, so this is minimum information required to create any layer. So after creating this, say OK. Here it is OK. So you might have noticed here the new file has created, this one, first one, igno demo. Now what you have to do, you have to edit it. Okay, so you want to edit it. So here it is toggle editing. I am just switching on. So now you might have noticed some pencils has created here. Okay, so you, after that you can just drag this one and create whatever you want. You can just click which layer you want to edit, that you have to write. So I just want to add some polygon like this, just making a dummy. Okay, so this is my polygon. Now you create your own point, own line layer, own polygon layer. Three layers you have to create. Okay, so you have to try different options like the I have added this polygon, but I want to make this into two parts. So I will cut two parts, three parts, or I want to edit, I want to extend. So all these options are here in this menu. You try it. Simple exercise, not much complicated, but you should must do once. It's a simple, but if you are not aware about the options, it will become difficult. Okay, so simply you have to digitize, create the layer and digitize it. Correct? See, why I am saying you have to explore, like I'm exploring this tool, vertex tool. See, using this I can change the shape. See, I have changed the shape. Okay, is it okay and easy exercise? I believe. So now, which layer you will take? Maybe you can take your this one, the toposit layer, and take a small portion of the toposit and create your own one point layer, one line layer, and one polygon layer. Okay. So how you will do it? You take any corner, not bigger area. So that purpose is not to digitize a bigger area, but purpose here is to uh, understand the purpose of this exercise and get acquainted with these tools. So select any area whichever you want and digitize features accordingly. For example, you are selecting, say, one point layer. So accordingly, you digitize any points available here in this map. Maybe location of the village you can take. If you are taking, say, line layer, so roads are available, some drainage lines are available. Take small coordinate only, need not to do much, but prepare a small area anywhere in the map which you want to take. You take a small area, one portion, maybe 5 by 5 is enough, one coordinate only, quadrant, not coordinate, one quadrant you take it and make a map out of it. Okay, and save all the layers. Why I am saying save all the layers? Because the same exercise we will take when you are going to the map composition. You are going to make a beautiful maps out of it. There we will take your this layer and we can use there. So need not to use any other layer. You can use your own map and you can create your own map composition when we are doing that particular exercise. Okay, fine. Any doubt in creating? No? So you please start doing. And if you don't want this toposit, I don't have any purpose of asking you to use this toposit. You can use any map. In fact, you can use satellite data also, which you use morning. Or if you have any other raster with you, you can use that also. Only thing, you save all the three layers at one place so that later on we can use it. Okay, fine. Karishma Aishi, okay, Abhimanyu, you start it. I think, see, I don't want to leave you untouched this part, because creation and editing vector, if you are doing any GIS project, it is unavoidable activity. You will face these vectors many times, so you should know, for example, one polygon you want to trim little bit, or one line you want to trim little bit, you should know the option where it is. Or if you want to quickly create a vector file which is having very few features, so quickly in 10 minutes you can create and you can do your work. So okay, I'll stop here, and you guys please start doing this, and we'll connect. I'll connect maybe after some time. By that time, I will be silent. So you continue, and if you face any difficulty, just let me know.